Yes, here record. Yeah, it's recording now. Okay, so yeah, I should have asked first. So everyone is okay with recording, right?
Yes, I think so. You are the one that is being exposed to the video.
Okay. 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 So now, now we have another object called run, and this object is the one that's going to connect what I called it like this data object, which is a catchment, has all the objects, and it's going to have all the result as well. But all the methods that is going to make the calculation, it is in another object. Okay, and this run object is the one that's going to connect everything. Okay, so you have to just import it. You don't need to instantiate it or anything. It has nothing inside. It's just going to link other objects. So to where it is, yeah. So inside, so you don't need to pass anything to it to instantiate it. So you just need to import it, and that's it. Import it, and you give it as a parameter the data object or the catchment object. And so after you give it, you call the method run Hapi, and this method is going to run everything inside. So everything is going to be done inside. So now you have nothing to do. You just
maybe two questions here for you. I think that are important for everyone. The first one is when you were loading the data, what is the name of the files? You load the folder, but is there any convention that you need for precipitation, evapotranspiration, and so on? Because you are loading only the folder. So inside the folder, what should I put? Just paste all the files there, and then what?
Okay, inside the folder, you are going to see my collab.
Yeah, but a bit small.
Okay, so I have to run this. So I already sent you this link. Okay.
Can you paste it in the chat?
It's already in the chat.
Ah, it's already in the chat.
Yeah. Okay. So I will paste it again here. This in the chat. Okay. So.
That's the Slack chat, not the
yeah.
Zoom chat. Okay.
Okay. So yeah, open the collab. I was actually hoping to, from the days before, I was trying to make you work on your computer, because this collab sometimes to do a very simple thing takes ages. So I did this as an emergency, but if you have the code running in your machine, it would be much better. So I have it here in Jupyter Lab, and I work with Spider, so I have it everything. But for the sake that some of you had errors, I did.
Yeah, but maybe I didn't want to distract you so much over the explanation that you were giving. I only wanted to clarify that if you could show us the folder that has the name precipitation CPC NOAA, so we understand what should go inside the folder and how does it look. And if we can put any name of the files or how it works.
Okay, you see my browser, my Explorer right now. So here is Chrome. Okay, so here's Hapi and data.
Inputs, okay.
So
meteorological data.
So calibration. So well, for Hapi, I was making it as an experiment. So I have this precipitation, so it is rasters. It's a folder of rasters, okay, full of rasters.
And the raster names doesn't matter.
No, it matters. That's very important. But everything is dealt with within Hapi. So if you used the objects that I did to download the data and everything there, so you will run everything smoothly. So
okay, for now on, you are just explaining that we locate the input files in the folder, but the assumption for now is that the input file is downloaded by your own tool, but also if someone wants to put their input file there, raster files, there's another procedure.
Yeah, tomorrow I will. I have. Tomorrow we will generate the inputs. So whatever whatever rainfall you get or whatever data you get, it has to be raster or netsdf. We can put it in the form that needed by Hapi. So yeah, what I can say right now is that the convention is that the name has to has a date, and this date whatever you write. Whatever you write the date, you have to give the form. So you write year, months, day, year, whatever. So you have to put this format, and Hapi is going to generate a number at the beginning to know the sequence. So what's before what? Okay. So here for Quello, I downloaded MSWEPE and NOAA and SHERPS, and here temperature. Yeah, it's everything is rasters. Okay, so
all the same convention. The convention is date extension.diff in this case,
yes.
and the name before.
Yeah. So I have a parsing method inside, so it is going to split this string with the format that you are going to get. So whatever format you called the file, it has to has a date, and it has to has this separate delimiter, and you give this delimiter. You put it a dot, you put it whatever. You have to give it to Hapi as you used it. Okay.
Okay.
So yeah, here after you give these folders, and yeah, it is going to read all of them, and it's going to stack them as a 3D array, and so this run object is going to take this data object, what I called it catchment, and it's going to connect it with the method that is going to run Muskingum and going to run the numbed model. Okay.
And another point or observation. So it will run from the first date till the end date of your data. And what happens if you put more dates in one than in another? More evapotranspiration than precipitation, for example.
No, it is not going to pass all of this. So whenever at the beginning when you start, so here this Quello object, the catchment object, doesn't do any verification on the inputs. The one that do the verification is this run object. So it is going to connect. Someone is trying to enter, or everyone is here?
Check out. I don't know. I have 16 now. There is one more than before.
Really?
That is okay. Yeah.
Okay. Yeah. So this object is the one that is going to compare everything. So number of rows and number of columns in the DM has not in the DM, in the flow accumulation, in the flow direction, and in the first 2 dimensions of the meteorological data has to be all the same. And if they are not, well, if you use Hapi from all the tools in Hapi, they are going to be the same. But if you decided to use to get the data from other source, I have the tools that you can use in order to match all the dimensions of everything. Okay, so this one is going to is going to compare everything. Everything is okay. It's going to start running first the vertical, the lambda for each cell. Then it's going to route it. The simulation is done. Everything is okay. Yeah. So after we go to extract discharge at the location, at the cells where the gauge are located, and it is just a method. You don't need to pass anything to it. So and we go back again to the Quelo object, to the catchment object. So this run object is just you instantiate it and you give it the data object, and that's it. The data object is going to be to have also the result. So what are these results? It is a state variable, all the state variables, snowpack, water content, soil moisture, upper zone and lower zone. And if you have a lake, you will have the volume of the lake. So this this array is 4D. So you have the 3 dimensions that we know, longitude and latitude, and in the other dimension the time. And for every value of longitude, latitude, and time, you have five of 4 state variables. Okay, so you have that's one of the result, state variable, and the other result is lower zone, the base flow discharge, and the other one is upper zone, the surface flow and interflow, and yeah, those are both of them are 3D arrays. So space and time, and Q total. Q total is summation of upper zone and lower zone, and what else? And you have the upper zone alone. So you have all the results stored in the Quelo object or the catchment object. And when you extract the result, it's going to extract. It's going to go to the Q total, and it's going to extract the column from at the location where all of these gauges exist. Okay. Because one problem that appears here, because when you resample and you make it like a very coarse resolution like this, you have error in the area. Okay, so instead of if the gauge was in this part of the river, it has a certain upstream drainage area. So if the gauge is here, it has, let's say it has 10 meter square, 10 square meter upstream drainage area. But after we digitize it and we have these squares, now sometimes it has more. So this part of the cell, it is generating more water than it should be. And in other places, if you have a gauge here, it should have water from this part, but now it has water from this part only. Okay, so you understand here? So there is a difference between what's real catchment and what we have because of this digitization. So if you have the real area of each gauge, and you have after this after we resampled, so if you want to multiply by any factor to correct the discharge, so you have a factor, you divide the area after resampling and the real area. So in order to have it as a reference and multiply it by the discharge, you can put it here. You can give it to this object. So when it is extracting the hydrograph from each cell, it's you have the option to multiply it by any number. If you did this, this argument is optional. If you don't give anything, that's not an error. Okay, and yeah, so it's also going to calculate all the metrics. So yeah, and after calculated, yeah, you can just write these simple lines to print what is the error. Okay, and yeah, another thing also.
Sorry, I have a question. This number that you said that you have to multiply this the area ratio, like you define it, or
Yeah, I define it. So I go back to, I show you the gauge. Here. So yes, so I said the philosophy behind it. So you can multiply any number, but the number that I was interested to see how much actually each gauge should cover upstream and how much it is covering because of this resolution. And so what I did is that I measured both area before and after the resampling, and I divided both of them. And that's a factor that I might. Oh, that's a factor that I multiplied the charge with. It is sometimes a factor of 0.97, 1.2, something like that. It should be here, but it's not here. But yeah, that's how the gauge file should look like. So it should have an ID, and yeah, that's a name. It doesn't matter, and it should have X and Y. Whatever the coordinate system, it doesn't matter, but it has to be similar to the coordinate system that you use for the DM. If it is not the same, we might have a problem like what we had in Coelho. Projections are very weird sometimes, and all of these global maps, it is in WGS 1984, and sometimes we have a problem. So it is better that you unify all your projections in ArcGIS. Hapi has all of these checks, and when it is resembling, when it's doing all of this, it is using GDAL, so it's basically the same like ArcGIS and QGIS, but sometimes I get some error.
So the maybe just to summarize what you are saying, this table will allow us to know the location of the gauge where you have some measurements.
Yes.
Right, and then the area, it's what I didn't get. So these are the gauges. Indeed, you probably have these 4 or 5 gauges, but the area is supposed to be associated to the path that you were talking a few minutes ago about the flow. So now I got confused exactly. What is this area that you are adding here? What is the parameter?
Real area. This area you measure it from ArcGIS. So ArcGIS or QGIS, it has an option that you give it the polygon, the catchment, your DM, and you put some gauge, some point and scattered in the DM, and after you do the delineation, you want to know how much upstream drainage area for each of these points.
Okay, it could be calculated automatically, but in this case, you are suggesting, or well, it's not done automatically. You have to go to
That's in ArcGIS.
ArcGIS, and then you have the value, and you put it here in each one of them.
Yes, not to put it in each one of them. Then you check with the resample DM after you. So these gauges, you get the drainage area, upstream drainage area with the very small resolution DM, the 30 by 30, and then you calculate them again with 5 kilometer by 5 kilometer, and you divide both of them. So you have real area and coarse area, and here you have a factor, and this factor, let's say this would become like 195. Okay, so you have this over this.
So both at the end are obtained from GIS, but one is based on the original data, which fine resolution, and the other one was with all the steps that you mentioned on the coarse resolution.
Yes.
My question is, how important is this? Do we really, how much could be the error? Because it seems quite a lot of details. If you put this 0.97.5 and the other one is 1, let's see.
It is sometimes it introduces a lot of error.
So it's very important to do that.
It is, yeah, and sometimes the calibration is trying to generate some discharge, and you have the gauge is supposed to have discharge from 4 or 5 cells, and because of this mislocation or this problem, you have it having water from 1 cell. So the calibration is trying to generate.
But this is also well documented in the part where you are showing how to do it with ArcGIS, right?
No, actually, that's not
okay. That I think something to add in the last part of the moment where you are making the change from fine to coarse. Then in that moment you should say, okay, calculate the coefficient, because if it's really important, it's good to have it in the instruction.
Well, okay. Well, yeah, here. So you see here, that's what I calculated for original area. And so you see for this gauge, the real area, it's 124, and it is half when we resample. So it has 1 cell, 4 kilometer by 4. So you see, sometimes the difference is very, very far.
And the weight, how did you estimate it? 1% of the total sum?
Yeah, this over this.
No, the weight, the last one.
No, this weight I was trying at the beginning to give importance to some gauges on top of other
the calibration
gauges.
Process.
Yes, but
Okay.
yeah, later I decided, yeah, all gauges are important. But that's
but
another...
indeed, this is a good thing. In fact, this is a really good thing of the gauges up and down streams, because in fact, sometimes, and we have a case where the gauges downstream are having some issues. They are so close to the sea that they have a influence of tides, and then they damage the measurement. So it's good to have calibrated upstreams where you have more or less control, and the other ones very low. But that's just a comment. Yeah.
Okay, so I didn't talk about the calibration at all now, but yeah, you opened it. I made the calibration. It's like very, very flexible. So you construct your objective function whatever you like. So if you have any argument that you want to pass it to Hapi, and Hapi pass it back to your objective function inside the calibration algorithm. So what I was doing is that I was summing all errors from all gauges, all equal weights, and another time I was multiplying with this weight. And this weight I calculated based on how much area does it have upstream. So yeah,
okay.
Calibration.
Just continue. Yeah, I think the calibration is a topic for tomorrow. Yeah.
Tomorrow, yes.
Yeah.
So now, after you extract and whatever factor you want to multiply, calculate it with any method you like. Just every gauge has to have one factor, and you pass it as a list. So whatever you do, you have 5 catchment, you have to pass a list of 5 numbers here to this method, and it's going to multiply it by a hydrograph. Then you have the hydrograph and you can plot it. Now, visualization, I have if you are familiar with the concept of subclass, superclass, and subclass. So at the very, let's say we say front end and back end. The back end, there is an object called visualizer. I have it in Hapi, and it is doing all the plotting. And in the front end, we have this data object, which I made it as a container. It has everything, the data, the result, and the method to visualize. Yeah, so this visualizer, it has animation for, it animate everything. If you have an array, you want to animate it, it can animate it. If you have another stuff, I did it for my PhD. If you have a flow in one dimensional hydraulic model, you can simulate it there. So anything that is plotted with Hapi is a method inside this visualizer, and I call it from back to any other object. So here in Quedo we have 5 objects. So in order to visualize it, you have to give the order and you have to give the date, and it is going to plot the hydrograph. Okay, so this method plot hydrograph, it can return, so any function or any method or function in Python, you can return value, and if you don't want to return anything, it's okay. So any plotting, any visualization in Hapi, it returns two things: the object of the figure and the axis. So this figure, yeah, I made yeah, every method can take a lot of other parameters, the title, number of ticks here, the size, anything. So, but if you don't like the way that I constructed this object, this method, and the argument that you have, I return back to you the matplotlib object. So you have total freedom to change anything. So yeah, so that's how the hydrograph looks like without any calibration, just by extracting the parameters from this global dataset. So you can start your calibration with this, with such hydrograph. I wouldn't generalize and say that it is good everywhere. Yeah, so this, yeah, this hydrograph here, yeah, this gauge, because it has a huge difference, the performance was very bad, but yeah, it's a good start. Okay, the other thing is that I put here animation. So we have a stack of rasters and we like to animate it. So also in this visualizer module that I have at the backend, it can animate array, 3D array. So yeah, it's a time series of a stack of arrays. It has a lot of arguments. You can control the animation whatever you like, and it's going to make an animation like this. So here you have, this is the total discharge. So similar, you can simulate soil moisture, you can simulate snowpack, you can simulate, you can animate upper discharge, lower discharge, any value that you have it stored in the catchment object, and it is a 3D array. You can plot it here, and yeah, I was trying to make the visualization more what can I say? Yeah, the scale here. So you can change it to bar scale. You can change it to logarithmic scale, because sometimes discharge all the time series has low discharge and 2 or 3 values has high. So it has a lot of options here. So yeah, there is 5 scales: normal, bar, everything you can do it here. And yeah, so this is you can also save this animation, but yeah, it needs to install some codec thing. So yeah, here is the way from where to download this codec and how to put it. And yeah, the last thing is that how to save the result. So this method, save result, yeah, you give it option result equal 1. It save rasters of discharge, total discharge. Option number 2, upper zone. Number 3, lower zone. State variables, everything you can save it in the form of raster. So yeah, so that's the last thing, I guess, for today. But if you like to try the code, so I already sent all the Jupyter notebook, and we have the collab thing. So you don't need to install anything. You just need to open the link and run it.
Questions? Yeah, if there may be still not questions, not only. Yeah, I see. I think it's maybe still there is no hands-on, so probably tomorrow that you start to do it all yourself first. Make one good example. Everyone just follow you and see what is the procedure starting from zero. Maybe not in a notebook. Maybe it's easier if we do it just in simple Spider. Just
okay.
Yeah,
hello,
Gonzalo?
I have one question. Sorry.
Yeah.
Just to say thank you for this time, because I think it's really interesting. And the another thing is, in Jupyter Notebook, the installation of Hapi is the same as is in the so to run it in Google Colab, because there is
Well,
no this. Okay, that's the question.
Well, Jupyter Notebook, Spider, Collab, all of these are editors, or yeah, so those doesn't matter. So yeah, it's not.
They are just front ends for the final Python behind. So at the
Yes.
end, it's just command lines. Yeah.
Where it is? Yeah, yeah.
Okay.
Talking about the installation. So yeah, we really, if you ask the guys from who tried Happy like a year ago or 2 years ago, we were struggling, but right now, I don't know.
Yeah, the guys are here. Fabio is here and Juan Manuel is here. Fabio, are you there?
Yeah, we're here. Yeah, sorry.
Yeah, before they were struggling. So you were saying, Mustafa?
Yes. So right now, you see my screen now or not?
Yeah, we can see it.
Yeah.
Yes, we are.
Okay.
Yes.
So I don't know what it is. So right now, well, I started actually not these days, but long ago. So right now we have Happy in all platforms that share open access Python or open access software. So we have it in Conda Forge. If you know about Python, so Conda Forge is a Conda channel for codes, and it has a lot of checks. So in order to pass and to publish your package there, yeah, it has a lot of let's say they call it continuous integration. So it has, I have to try my package in Windows, in Linux, and in Mac, and I have to try it on all versions of Python and all versions of all the packages, the requirement, the other libraries. So all of this I have already done, and it is already, yeah, so it is there. I published it 2 days ago, and it is already 135 people downloaded it there. And in Beep, if you know Beep, I bought it there like a year ago, and it's already 7,000 people downloaded it. Yeah, so it's everywhere.
Yep.
So
In other words, maybe aside of the technical component, is now it's very easy to install. You just say pip install Hapi and it will install Hapi, or you say conda install Hapi and it will install conda.
exactly.
Yeah, so that's maybe the basic. Now it's really fast. What maybe just to clarify that Mustafa was telling everyone to go to the GitHub and look into the GitHub was more to be able to see the code as he was explaining today. But most of the time, or most of you will be just if you opt for using it, then it's just going through it as we are going to do tomorrow. Today was more explanation, such that if anyone wants to change, modify, update, or even understand very well, which I think is very important, what is the code, where are the variables, what can you extract, what is what, maybe today I think was the right day.
Yeah, and other things that, yeah, Happy is using a lot of other modules. Some of them are very famous, like GDAL or NumPy, or all of these modules. Yeah, these modules are very famous, and yeah, a lot of people are behind them, but still they have errors. And once they have errors, and you don't really know what you are passing to Happy, and you got an error at the background, yeah, it's probably because of GDAL. So today I got error, and I thought that, yeah, I'm passing wrong pass to the data, and yeah, so there is still errors. Okay, and I cannot figure it all by my own, because I developed this and I know exactly how to do it, and I know how to figure any error. But yeah, when other people try it, yeah, of course you will have some difficulty. It's not
Perfect.
a walk in a park. Yeah, so yeah, I need other people to try the code and tell me.
Yeah, so you are all welcome for feedback. I mean,
yeah, exactly.
To give you feedback.
I have a question here.
Mhm.
I don't know if you have time for it.
Yeah.
Okay, Mustafa. First of all, thank you for this presentation and for your time. This is such an endeavor. I'm just the user of a hydrological model. I'm using SWOT model, and it's very hard just being the user and try to prepare all the input data that we need there. So I cannot imagine how is the task if you are trying to code what a hydrological model does. And my question is related to that. Mustafa, I'm already a SWOT user, and I would like to ask, or I was wondering, maybe you, or of course you as the developer can answer this question. If I'm already the user of a model that is, let's say, common, what are the main advantages of this model? There are some advantages that are obvious. For example, if this is open source, it's a distributed model. But below that, you as the developer, what are the main components that makes this hydrological model something different from the other one? And me as a user, what are the difference that I will see when I'm checking my results or things like that? And again, thanks for that. This is an amazing job what you are doing there.
Thank you. Well, I was trying to make it as flexible as possible. So yeah, so the main point is that it is very flexible. So whatever the objective that you want to do, I guess it can do it. So yeah, all these objects that I did at the beginning, it was not there. So I introduced a whole GIS modules and a whole visualization module. I developed the whole calibration algorithm behind it. So I would say it is very, very flexible. Yeah, the calibration is also flexible for it. Yeah, and it's very, very customizable. So whatever your object it is, yeah, even if it is not there, I can develop it. So yeah, the ideas that I have now, and I want to do it further. So there are a lot. Before with another student with Gerald, we were going to do water allocation model. So right now it's very easy to do it. So I'm thinking to do it, and yeah, for also my PhD, right now it's very easy to do a 2D hydrodynamic model on top of it, and 1D. So instead of this Muskingum, I can introduce the real river. So it is very, very customizable. So at the beginning,
maybe just to highlight what about the water allocation model, it's in fact what is similar to what is in the other software from the University in California or the SE, which is the WIP that has a water allocation model. So few softwares use this concept. So that is something that we had in mind with Mustafa, to have the possibility to include reservoir, irrigation, cities, and then you can have a water balance that you can know how much every person is taking every day or every month. So that was really nice concept. Yeah.
Exactly. So yeah, specifically talking about this week. So at the time that I was doing my master, I had a colleague, and she was doing reservoir optimization and water allocation optimization with WEAP, and it was very hard to optimize the vertical component, the lambda model that they are using in WEAP. She didn't like it at all. It was but it was not customizable. She cannot do anything coupling WEAP with other optimization to calibrate the model was very hard. So all of this, I was very keen to make it as flexible as it can. So if you don't like the calibration algorithm, the optimization algorithm that I have in Hapi at the back end, so I made it easy to use it. But if you don't like it, so there are a lot of other very famous optimization algorithm like Deep and a lot of other algorithms. So it can work with what I have, and it can work with, you can couple it with any other model. So I would say that's the biggest sell point, I would say, that I have here. Yes.
Okay, thank you so much.
Thank you, Mustafa. I imagine that maybe there are more questions, but I have to leave now. I don't know if anyone wants to make more questions now, or we maybe meet again tomorrow and then we do the questions when you manage to play a bit more with it. Yeah, open questions.
I
open
have a
answers.
question. If we come up with questions, but later, can we write like in a Slack or in the other one? It's because you post a link, I don't know,
Yeah,
from for another place, but I don't know if we should ask questions there or in the Slack.
Right now in the Slack is okay, but yeah, I will leave Slack for another couple of weeks, and then later I will delete it, and we will continue in this. Yeah, I'm trying to build a community for Hapi. So this Gitter, it will be open all the time, and you can all join there. So short answer, Slack is for another couple of days, and I will close it.
Okay, great, thank you.
Good. Okay, then thank you everyone. And tomorrow then at what time, Mustafa? 3 p.m.?
Yeah.
Yes. Okay, 3 p.m. Dutch time or German time. The same time. Okay. Thank you everyone, and then have a nice evening and a nice afternoon for those that are in Colombia or in other place. Okay. See you guys.
Thank
You
you.
too. Thank you.
Bye-bye.
Thank
See you.
you.
Thank you.
Thank you.
Thank you. Bye-bye.
Bye.
Bye.